Okay, we also have focus, but now we've seen focus in the parabola. It's outside the parabola. Here, focus is going to be inside the parabola. So it's going to be somewhere here. We can put F for focus, and then the center, we can call it with a C. Now, notice that we have two focus. And then the plural for focus is foci. A lot of people want to pronounce it with you'll pronounce with the S. So you pronounce it foci. Right, so you pronounce that C with an S, foci. That just indicates that we're talking about two focuses. It's going to get a little messy on this diagram, but we also have something called A, B, and C values, and that's going to help us create what we need for our equation. Notice that this kind of looks like the circle equation. You got the x minus h squared, you got the y minus k squared, but because along the horizontal and vertical you have different lengths, that's going to allow for us to identify the A and B value. Okay, and no longer do we have one radius, so it's always going to be equal to 1, and then the A squared and B squared indicates the distance. It's kind of like your p-value for a parabola, where you count from the center to a point that you're trying to find. So your A value is always going to be the longer length from the center to the vertex. Your B value will be the shorter length from the center to the covertex. And then your C value, which we don't see in the formula, but it's going to be helpful for us to find other things, it's going to be the distance from the center to the focus. Okay, let's look at the other orientation of ellipses. That's where we're going to have a vertical major axis. Now we're going to create an ellipse where it's longer along the vertical side than it is along the horizontal side. Okay, so now the major axis is going to be along the vertical. We say the word major to indicate that it's a longer side. And the major axis will always connect from vertex to vertex. Same thing in this diagram. Your major axis will always connect vertex to vertex. Okay, your minor axis, in this case, is the shorter one along the horizontal, and the minor axis will connect from covertex to covertex. very similar information we're going to put onto this diagram. Your your focus is always going to be along the major axis. So here the focus is along the horizontal because the longer axis is horizontal. But now, because our major axis is along the vertical, our focus is going to be along the major axis. And then the center is here. Same as before, your A value is the distance from the center to the vertex. Your B value is the distance from your center to your co-vertex. And then your C value is the distance from the center to your focus. Thanks. Okay, we also have this this value called eccentricity. So eccentricity tells you basically how circular your graph is. So eccentricity is always going to be between 0 and 1, and you're going to find your eccentricity by dividing C by A. So closer you are to 0, the closer you are to a circle. The closer you are to 1, the more oval your graph is. Okay, so we can refer back to this diagram as we work through our problem. So let's look at number 1. Graph the ellipse, state the center, vertex, co-vertex, foci, and eccentricity. So the center, you find the same way as circles. You just pull from your H and K value. They are inside the parentheses next to your X and your Y. Oh yeah, before I do that, let me go over the formulas here. So if you're dealing with the horizontal major axis, then your A value is always going to be below your X, okay? Because the longer axis is horizontal, my A value is always going to be the longer length, so that's always going to go below your major axis. And then your B value, the distance from the center to the co-vertex, is always going to go under your minor axis. For vertical major axis, because my vertical is the major, I'm going to have the A value under the major axis and the B value under the minor axis. Okay, so your A is always under the major axis, and then your B is always whatever variable is wherever the minor axis is. Okay, so determine your A and B value. You always look to see which one is larger. Okay. So because 4 is larger, I know that 4 must be referring to A squared. So I can put that to the side. I know that A squared is equal to 4. And because 4 is under the X, I know that this is going to be a horizontal major axis. I know my graph is going to look more like this. Right? It's going to be longer along the horizontal. So if A squared is 4, I know that my B squared is equal to 1. And if A squared is 4, I can take the square roots. So A must be 2, and B must be equal to 1. Okay, let's do the vertex and co-vertices first, and then we'll talk about how to get to the focus or the foci. So start with your center, 3, 1. You know that your major axis is horizontal, so you're going to follow that as your A value. So you're going to go over 2 and to the left and to the right 2 units, because you know that you're going to be finding your vertex going left to right. You can go ahead and label them as your vertex, as your V. All right, your A value is, sorry, your B value is 1, so you know that's going to go along the minor axis, the vertical. So you're going to go up 1 and down 1. It's a really small ellipse here. Okay. Let's go ahead and, now that we plotted those points, let's see if we can identify those order pairs. Okay, do you guys get the same thing? 1, 1, 5, 1, 3, 2, 3, 0. Okay. Now, to find the focus or the foci, there's a formula that we're going to use. Right? And the equation that's going to connect A, B, and C together kind of looks like Pythagorean theorem, but not quite. It's going to be A squared minus B squared equals C squared. We have A and B, so we can find our C value. Okay, I'll put this below here. So A squared is equal to, or A squared minus B squared equals C squared. Yes. Okay, so my A is 2, my B is 1, or I can just do A squared minus B, 4 minus 1. So C is equal to root 3. Now, just for our estimation, we know root 3 is some value greater than 1, but less than 2, right? You know 2 squared is 4, and the 1 squared is 1, so it's going to be somewhere between 1 and 2. Let's just say 1.5, okay? So you're going to use the C value to help you get to the focus. So C value is going to be the distance from the center to the focus. So I know this is a really small diagram here. We'll just go 1.5. And your focus is typically going to be closer to your vertex than it is to the center. So sorry for starting off with a small diagram here, but just try your best to label that as your focus and label that as your focus. Now, we're not going to find the exact decimal value. So the way that you're going to do this is, you know that your focus are all going to have a same Y value of 1. It's just that you are moving left and right of the center. So the way that we can represent that left and right movement without having to go through all the decimals is we just say that it's, we're taking 3 and we're doing plus or minus root 3 to move left and right. So we say 3 plus or minus root 3, but then the focus are all staying at a constant value of 1, right? The Y value is the same. It's just that we're shifting the X values left and right. So we could do 3 minus root 3 and 3 plus root 3 and find the decimals, but this is a shorthand way of representing those two order pairs without having to write a whole bunch. Okay, eccentricity, we do C over A. That's the formula. So we take our C value, which is root 3. We take our A value, which is 2. So just C over A, which is root 3 over 2. Okay, number 2. Okay, x squared over 9 plus y plus 2 squared over 25 equals 1. Okay, let's find the center first. What's the center of this ellipse? Guys. Yeah, so 0 from the x and -2 for the y. Okay, now look at the 9 and 25. Right? The larger value is below the y, so you know that this 25 is referring to the a, right? Your a value is always larger. And depending on whether it's under the x or under the y, that's going to tell us what the orientation is going to be. Okay, if it's under the x, then you're just going to know that your graph is going to be more horizontally longer. And then if your a value is under the y, then you know it's going to be a more of a vertical orientation. Okay, so we know that a value is below the y. We know it's going to be a vertical axis, so we know how the graph is going to look. Okay. Notice, make sure that you understand these are not a and b values. These are a squared and b squared. So we got to take the square root to get it down to the a and b value. So a squared is 25, which means a is 5. B squared is 9, which tells us that our b is 3. Okay, so starting at the center, you're going to count up and down 5 units to get to your vertex. Okay, so 0, -2. A value is 5. My a is below the y, so that's going to remind me to count up and down. Go ahead and label V for vertex. My B value is 3, so that's going to tell me how far to move from the center to get to the co-vertices. Okay, so read your graph and identify those ordered pairs. Okay, before we get to the focus, let's find the C value. The formula is a squared minus b squared equals c squared. A squared is 25, b squared is 9. C squared is 16, so C must be what? 4. Okay, so to get to my focus from the center, do I count vertically or do I count horizontally? Vertically. Okay, so your focus is always going to be along your major axis. It's going to be along the same axis as your vertex. So wherever your vertex is, that's going to be where your focus is going to go along as well. So 4 units. In this case, looks like we're getting an easy number to plot, so we'll just go ahead and identify those points. But if it's a radical, then typically we just write it this way, so we don't have to write it out. We have to represent with decimals. But here, we should be able to plot these easier here. Eccentricity is your C over A value. So my C value is 4. My A value is 5. So 4 over 5. Okay, so today we're just going to focus on what we did on this first page. Okay, just trying to identify our A, B, and C value, all the order pairs that we need, the focus, the eccentricity, and to be able to graph it. Okay. Okay, so our classwork is page 17, but I'll work alongside you guys so you can check your work. Okay, any questions so far? Okay, again, look to see what is larger in the denominator. Okay, whatever is the larger value is your A value or your A squared. And depending on whether it's under the X or under the Y, that's also going to tell you how the graph's going to, how the ellipse is going to look, right? Is it going to be longer along the horizontal or is it going to be longer along the vertical? Does anybody still need this page? Okay, maybe go a little bit off the graph here. Guys, for now, you can use your calculator just to get more accuracy in terms of these decimals or these radicals. If you're moving along the horizontal axis, then you can just do plus or minus to the x value of the center to move it left and right. So that's a quick and easy way to write the focus. You just take your center, depending on if it's moving left or right or up and down. If it's moving left and right, you're just going to attach your C value to your X of your center. But if your focus is along the vertical, then you're going to add your plus or minus your C value to your Y value, to your Y of your center.
Can you quickly explain how you got the eccentricity?
Yeah, eccentricity is just your C over A. That's the formula for it. It's just C divided by A. So my C value is 2 root 14, and my A value is 9. So it's just 2 root 14 over 9. Yeah. Okay. C value is 2 root 14. My A is 9, so 2 root 14 over 9. Yeah. Okay, number 2. Notice the 64 is under the X, so you know that it's going to be more of a horizontal ellipse. Okay, it's a very narrow ellipse here. Yeah, your focus is going to be almost right next to the vertex. Notice that you're moving your focus horizontally, so that's going to impact the x value of your center. So just take your center and do plus or minus to the c value. That's going to allow for us to give an exact value of that focus. Yeah, you're just writing the center, and then you're just doing plus or minus c to the appropriate x or the y value so that you can move it to those locations. Okay. I'll show number 3 in a second after you guys had a chance to try it. But just take a look real quick at number 3 and 4. What's noticeably different about 3 and 4? Yeah, good. So you see the larger value now is under the y. So both 3 and 4, you're expecting a vertical orientation, vertical major axis. Okay, does anybody still need to look at number 1 or 2? Notice that because your focus is along the major axis, it's along the vertical. So when you write your order pair, you're going to write your center, but then you're going to do plus or minus to the y value because you're moving that focus up and down, or you're moving the center up and down to reach the focus. Let me know if you have any questions, if there's any parts you want to go over with you. Give you guys a few minutes to finish. I'll come around and I'll check pages 16 and 17.